Dear learners, I am Dr. Biswajit Mahanti, Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. Already we have started some numerical on op-amp. In our last video, we have done so much numerical. So today also, we'll go for few more numericals. Those are very much useful for different competitive exam, GATE and BTEC semester exam, mid-sem, all those things. So my dear student, the first numerical for today's session is that, so first I am writing the problem 1. What is that? When a voltage V1 is equal to plus 40 microvolt is applied to the non-inverting input terminal and a voltage V2 is equal to minus 40 microvolt is applied to the inverting input. Inverting terminal of an op-amp and output voltage V0 is equal to 100 millivolt is obtained. But when V1 is equal to V2 is equal to plus 40 microvolt, one obtained V0 is equal to 0.4 millivolt. Calculate the voltage gain. Calculate the voltage gains for the difference and the common mode signal, and the question is and common mode signal and the common mode signals and the common mode rejection ratio. So this is the problem. So now we'll go for solution to solve the problem. Answer. In the first case, the difference signal Vd is equal to V1 minus V2 So what is V1? V1 is equal to 40 volt. V1 is equal to 40 microvolt. V2 is equal to minus 40 microvolt. So 40 minus 40, that is 80 microvolt. And the common mode signal, this is a difference mode, this common mode signal is VC, common mode, and difference mode signal VD. So common mode means average V1 plus V2 by 2. So 40 minus 40, by 2, that is equal to 0 volt. Now the output voltage. What is the formula? Output voltage V0 is equal to AD into VD plus AC into VC. We know that AD is equal to voltage gain for the difference signal. For the difference signal, AC is the voltage gains for common mode signal. The AC AD we understand. So now we got VD So we got VD and VC. We got VC, VD. So here we will get VD and VC. Okay. So now V0 is equal to V0 how much? V0 is equal to 100 millivolt. See the question. V0 is equal to 100 millivolt. So V0 is equal to, so what is the formula? V0 is equal to AD VD plus AC VC. But here VC is equal to 0. We got VC is equal to 0. VC is equal to 0. So V0 is equal to AD VD. So AD, how much VD? VD is equal to 80 microvolt. So AD into 80 microvolt, and V0 is equal to how much? I told you 100 millivolt. So 100 millivolt, that is equal to AD into 80 microvolt. So millivolt we can make it microvolt. So 100 into 10 to the power 3 microvolt is equal to AD into 80. So AD is equal to 10 to the power 3 divided by 80. So that will give you 10 to the power 5 divided by 80. So that will give you 12.1250. 1250. So AD, therefore AD is how much? 1250. So that will be the one more expression. Okay. So that is nothing but 1250. Now second case. In the second case, so case 2. Case 2, what happens? Second case, V1, V2. Second case. What is that? V1 is equal to V2 and both are 40 volt, and V0 is equal to 0.4 millivolt. So second case, case 2, VD is equal to difference voltage V1 minus V2. So 40 minus 40, that is 0, 0, and Vc is equal to V1 plus V2 by 2. So 40 plus 40 by 2. So 80 by 2 is equal to 40 microvolt. Now again the same formula. This is the most important formula. This one. V0 is equal to this one. V0 is equal to AD VD plus AC VC. Here VD is equal to 0 volt. So V0 is equal to AC into VC. Here VC is equal to 80 microvolt and V0 is equal to 0.4 millivolt, I think. 0.4 millivolt. So AC is equal to V0 by VC. V0 is equal to 0.4 into 10 to the power 3 divided by VC is equal to 80. So if you calculate it, it will give you 10. Give you 10. So AC is equal to 10, and before the previously VC is equal to 40. VC and VD. AD is equal to 1250. So now common mode rejection ratio. So now common mode rejection ratio. This is very, very important. Please remember, common mode rejection ratio is AD by AC. What is AD? 1250. What is AC? 10. So 1 to 5. So common mode rejection ratio is nothing but 1 to 5. This is the final answer. So we calculate the voltage gain. So we calculated voltage gain, that is AC and AD for the reference and the common mode signals. So we got, and CMRR also got. So this is very important question. VVI, very much important. Now we'll go for problem number 2. Problem 2. So my dear student, follow carefully all those numericals. These are very much important. So much important. Now a ramp voltage of 1.5 volt as shown in the below figure. .5 volt per millisecond is applied to an op-amp differentiator. Applied to a differentiator having R is equal to twice kilo ohm and C is equal to 0.01 microfarad. Find the output voltage and its waveform. Now answer. What is that? As ramp. So we draw the ramp signal first. This is coming and this like this. So in this direction time, in this direction amplitude. So here 0 volt, here it's going like this. After that constant 1.5 volt, this peak voltage, it is 0, and this time gap is from this to this is 1 millisecond. So this is the given. So this is t is equal to 0 and here t is equal to 1 millisecond. In this range we have to find out the output waveform. Now the output voltage V0 is equal to minus RC dVi dt. Here Vi, that is the input voltage, is as shown in the previous previous figure. This is Vi actually. This is only Vi. This waveform. Now this is 0, t greater than 0 and t less than 1 in this range. This is 0, 1. So this range basically t greater than 0 but t less than 1, this range. So for that range, for 0 greater than t greater than 1, for this time interval, this millisecond, dvi dt, what is the voltage difference is 1.5 volt divided by time is 1 millisecond, because dv is this, dt is this, 1 millisecond, this is 1.5 volt. And any other case dvi dt is equal to 0, because here dvi dt 0, here also dvi dt is equal to 0, this region also, only here exists dvi dt. And what is RC value? R is given 2 kilo ohms and 0.01. So twice kilo ohms into 0.01 microfarad. That is RC. Now V0 is equal to minus RC dvi dt. Minus RC means twice into 10 to the power 3, 0.01 into 10 to the power minus 6, because RC, into dvi dt means dvi dt is 1.5 volt by 1 into 10 to the power 3 second. So if we calculate it, it will give you minus 30 millivolt for 0 less than t less than 1, this range, that is V0. Ten to the power minus 3 actually. This is 1 millisecond, so 1 into 10 to the power minus 3 second. So this gives minus 30 millisecond V0, and V0 is equal to minus 30 millivolt for 0 less than t less than 1 millisecond, and that is equal to 0 for otherwise. Now the waveform. Now this voltage is fixed for this range, so make it like this. This one, this is 0 volt. This time is 1 millisecond. This amplitude is minus 30 millivolt. This is the case. So this is problem number 2. Now we'll go for problem number 3. So these are very interesting problems. Now let us consider very simple problem. The inverting amplifier circuit has R1 is equal to 1 kilo ohm and RF is equal to 3 kilo ohm. Determine the output voltage, input resistance and the input current for the input voltage of 2 volt. So these are given. Now the solution. Answer. So what is the inverting amplifier? So for inverting amplifier, V0 is equal to minus RF by R1 into Vi. RF is the feedback resistance, R1 is the input resistance, and Vi is the input voltage. So what is the minus RF? RF is how much? 3 kilo ohm. What is R1? 1 kilo ohm. What is Vi? 2 volt. So how much? 6 volt minus. Now input current. What is input current? Now we can draw the inverting amplifier. Minus, this is plus, this is grounded. Here one resistance R1, here one resistance RF. That is V0, this is RF, this is R1. Here the input voltage Vi. So this point is ground, this is also ground. So current is flowing like this current is flowing like this. So what is the current? This is I1 input current, this is IF feedback resistance. feedback current. So I1 is equal to Vi by R1. So V1 is 2 volt, R1 is how much? 1, I think, 1 kilo ohms. R1 is 1 kilo ohms. So 1 kilo ohms. So how much? 2 milliampere. So answer is 2 milliampere. So input current is of 2 milliampere. This is the final answer. This is problem 3. Now we'll go for problem 4. Now we'll go for few more numericals. Problem 4. Calculate the actual voltage actual output voltage of an integrator the 2 second for the output voltage. So calculate the actual output voltage of an integrator after 2 seconds for the output voltage for the input voltage of 1 volt DC, given that input resistance is equal to 100 kilo ohms and the feedback capacitance CF is equal to 1 microfarad. Now answer. Now what are the given parameters? What are the given? Input resistance, input resistance 100 kilo ohms R1, 100 kilo ohms. Feedback capacitance how much? 1 microfarad. One into 10 to the power minus 6 farad, and here 100 into 10 to the power 3 ohms. Input voltage Vi is equal to how much? 1 volt, and time is equal to 2 seconds given. These are given parameters. So now, as per the formula of integrator circuit, V0 is equal to minus 1 by CR 0 to T Vi dt. So 1 by CR minus C is equal to 1 microfarad, so 10 to the power minus 6 farad into R is 100 kilo ohms into 10 to the power 3 ohms. Then integration 0 to 2. Vi is 1 volt, so 1 into dt. So it will be 3 into 10 to the power 5, so 1 minus 1 by 10 minus 1 into 0 to t dt, t 0 to 2, so 10 minus 10 into 2, so minus 20 volt. Therefore the output voltage from the given integrator circuit V0 is equal to minus 20 volt. This is the answer. So this is problem number 4. Problem number 5. Problem number 5. It's very simple only. An inverting amplifier has R1 is equal to 20 kilo ohms and RF is equal to 100 kilo ohms. Find the output voltage and the input current. Input current for an input voltage of 1 volt. Now answer. What are the given here? Input resistance R1 20 kilo ohms, 20 into 10 to the power 3 ohms. Feedback resistance RF is equal to 100 kilo ohms, that is 100 into 10 to the power 3 ohms. So output voltage V0 is equal to minus RF by R1 for an inverting amplifier into VI. So minus RF means 100 kilo ohms, 100 into 10 to the power 3 divided by 20 kilo ohms, 20 into 10 to the power 3 with a negative sign. So minus VI is how much? 1 volt. So this is cancelled out, this is 5, so minus 5 volt. So the output voltage from an inverting amplifier is of minus 5 volt. Now the input current. The second question is the input current. So input current as per given circuit earlier for an inverting amplifier VI by R1. So VI is equal to 1 volt, R1 is equal to 20 kilo ohms. So 0.05 milliampere is the input current. The input current. So these are very important numericals. How many we solved? The problem 1, so much important. And problem 2. Problem 2. Problem 3. Problem 4. Problem 5. So this is all about today's solution. Final, the last numerical, problem 6. The non-inverting amplifier circuit with RF is equal to 5 kilo ohm, R1 is equal to 2 kilo ohm. What is the voltage gain? So as per our knowledge, answer for the non-inverting amplifier, V0 is equal to 1 plus Rf by R1 into Vi. From there, gain is equal to V0 by Vi is equal to 1 plus Rf by R1. So 1 plus Rf is how much? 5 kilo ohms. R1 is 2 kilo ohms. So 1 plus 5 by 2. So 1 plus 2.5. So 3.5. So the gain, hence the gain is equal to 3.5. The final answer. So this is all about our today's numerical. We will come again with new video with new problems. Till then, stay tuned. Thank you.